Hello everyone, how are you all doing? So let's begin today's class. So in the last class we completed inner join. So can you explain what an inner join is? So inner join is if you wanted to join two sets of data from two different tables, whatever matching data we can join together, we exclude the ones that we don't match, keeping only the ones that match. So basically, when you are combining the data of two tables, two sets of data, you are combining the data of two sets of tables. For example, let's say um, we have we are seeing the employees and department table. So the inner join will cause match with the information they have in common and exclude the information that doesn't match. The system will handle it itself. You won't have to do it manually. Another thing to mention, inner join won't work on without the on clause. Okay. When you use the inner join, it combines the data from the two tables that they have in common and excludes the data that doesn't match. Now we need to understand the left join. Similarly, we have left join and right join. Now, can you tell me from the query which table is considered the left table and right table? So the employees table here is considered the left table and the department table is the right table. Ah. When using the inner join clause, it helps us to understand the left and the right tables. In the left join, the data from the left table is retrieved first. Then the left side data is retrieved second. For example, in this particular table, the employees and department table, when using a left join, the left side of the table, which is the employees table, gets priority. It is retrieved exactly as it is created, regarding of whether it matches the data from the right table. Similarly, when using the right join, the right side of the table gets priority and retrieved first. So when using the left join, the left side table gets priority, and when using the right join, the right side of the table gets the priority. For inner join, no table gets priority. It only retrieves data that matches between the two tables. So here let's see query. Here you can see we have used left join. With the left join, we can see before because the left table gets the priority as it's retrieved here from the table. So let's modify the query to retrieve only the first name of the employee's department ID and department name using the left join. So after writing this query, you can see here, when we run this, it retrieves the first name, department ID, and department name, prioritizing the left table while including only the matched data from the right table. So you can write select employee's first name, employee's department ID, department dot department name from employees to and use the left join departments. When we run this, it retrieves the first name, department ID, and department name, prioritizing the left table while including only the matched data from the right table. To understand how the right join works, let's consider the employee and department tables. Again, a right join prioritizes the table on the right side from the join clause. So here we can see that we have written a query on right join. Select from employees right join departments on employees to departments ID equals departments dot department ID. In this result set, all rows from the right table are included. Rows from the left table that do not match the right table are shown in the null values. To identify null values in a column, you can use the isNull command. So, for example, here is the isNull command. Select from employees where commission is null. The query retrieves all employees who do not receive a commission. Okay. To retrieve rows where commission underscore PCT is not null, use the is not null clause. So instead of is null, you can write not null, and it will show that where they show the values of the employees who receive commission. Now, what is a coalesce? The coalesce function replaces null values with a specific default value. So here you can see select first name coalesce and inside bracket you can write commission and write within quotation mark no commission from employees too. So if the commission is null, it will be replaced with no commission in the result set. If the column commission with default, so the commission with default provides a more organized view of the data. So in SQL, a null value represents missing or unidentified data in a column. For instance, in our employees table, the commission underscore PCT column contains null values, which can sometimes make it harder to analyze the data effectively. So you can add column dynamically by combining salary and commission into one column to display the total income. So to do that, here is the code. So here you can see that We have combined the salary plus commission into one table and showing it here with the help of this query. Okay, you can also write different queries like selecting calculate the monthly commission of employees based on their salary and commission percentage, then combine salary and commission into one column as you have seen here. If you encounter unexpected results like null showing up in the calculations, double check the column values and ensure you have replaced nulls using coalesce. So I'm showing you more queries. So you have it is showing now we can compute the monthly salary, assuming it includes the salary and the commission. So we can write select first name, then salary plus salary into coalesce, uh, then bracket, commission, comma, zero, then close the bracket as monthly salary from the employees table. After running this query, you can see that we are seeing the first name and the monthly salary of the employees. Now, like this, you can calculate also the yearly salary. In order to do that, you can write select first name, last name, then write a query which shows the monthly and yearly salary. And after running this code, you are seeing the first name, last name, the monthly salary, and the yearly salary of the student. Sorry, the employees. So the coalesce and salary comma zero function ensures that if salary is null, it will be treated as zero. Similarly, coalesce then salary into commission underscore PCT comma zero replaces null results with zero. And for the calculation of monthly salary, we can say sum of salary and commission. And for yearly salary, you can write monthly salary multiplied by 12. So you can also change the order of the column, the results, use a simple select statement and list the columns in the desired order. For example, you can write last name first, write select last name first name, then salary from employees table. You should ensure that all opening parentheses have corresponding closing ones. Use meaningful alias for calculated columns to improve query readability. And run smaller parts of your query step by step for debugging the error. So I know some of you might find automation intimidating. You may think coding and automation, it can be super tough. But let me tell you, automation isn't as difficult as it seems. In fact, once you get the hang of it, it can feel even easier than manual testing. So you can think of SQL as a part of automation, but no, actually SQL is part of manual testing too. When we talk about coding and manual testing, it's not about complex coding you imagine in automation. It's pretty basic, like retrieving data, validating database entries, things like that. So don't get scared by the term coding here. We're talking about something manageable. For now, don't stress about automation or what's left to learn. Focus on what we are covering. Automation involves parts like API testing, Postman, Java, Selenium. So don't worry, we'll go step by step. By the time we get there, we will already have a solid foundation. So SQL is about database testing. While earlier we focused on UI testing, so imagine your desktop. You see buttons, links, and visuals, right? When you click on something, you are interacting with a graphical user interface. So testing these elements, ensuring button works, links lead to the right pages. That's UI testing. Now, when you log in, for example, your username and password are stored in a database. Testing whether this data is saved and retrieved correctly is database testing, which we do on the SQL. And once we start the API testing, you will see how everything is interconnected. APIs act as a bridge between UI and the database. Now let's talk about something special. You have been using the MySQL Workbench graphical user interface to run SQL commands. But there's another way. The MySQL Command Line Interface or CLI. To access it, search for MySQL Command Line client in your system, open it, and you will see a black window with a blinking cursor like this one. So here you can write, you can enter and write. To see all the database, you can write show database and hit enter. You will see the list of database. So if you want to work with a specific database, let's say Word, you will use Word. Once you are inside the database, you can view the tables with show tables. From there, you can run the same SQL queries we practiced in the GUI or graphical user interface. The result will appear here in the text form. So before we move to the API testing, you can practice some homework like color coding and practice, then slide, then command line interface practices. So you can practice all the SQL queries in the CLI. So let's introduce ourselves to the API testing. So this is an important part of the automation testing. So when you use an app, the UI lets you to interact with it. But the actual work, like retrieving data, performing calculation, updating records, that happens through API. API connects the front end with the back end. So we'll cover how the APIs work, using tools like Postman to test them, writing automation scripts for API testing. For today, let's focus on understanding the basic. Once we're done, we'll have plenty of time to practice before the next class. So API is the messenger between the database and front end. So API stands for Application Programming Interface. It acts as a set of rules and protocols. Think of it as a waiter and in a restaurant. When you are a restaurant, So when you are in a restaurant, you tell the waiter what you want. The waiter then goes to the kitchen and communicates your order and brings back your food. Similarly, API takes your request, communicates with the server or database, and brings your response back. So, what does API do? So, API receives request. So, API receives request from the client, which is the end user or the application. Then API sends request. The API forwards the client's request to the appropriate database or server. Then it responds back. API retrieves the server's response and delivers it again back to the client. So imagine you are logging into a website. You enter your user ID, password, and click on the login button. So after clicking on the login button, API receives your login details and goes to the server. Sends a request to the database to validate the credential. If the credentials are correct, the API brings back a successful login message. If the credential is wrong, it breaks up an error message, which is invalid password. So it responds. So why API testing is necessary? API testing is necessary because from the front end, you may see an error message like invalid password. So let me show you. It is a GUI API database. However, the issue might be in the API, not your credential. For example, API might fail to send the request to the database. API might face network issues while responding back. So API testing ensures that the request response process is error-free. So in order to understand the request and response cycle, for request API receives the input from the front end, then process API sends the output to the database, then response API brings back the response from the database to the front end. Now API use specific formats to communicate with the front end. It has JSON, XML, HTML. So JSON is a JavaScript or a object notation. It is the most commonly used format. It's lightweight and easy to read. For example, it displays error messages like invalid password or success messages. The XML, which is Extensible Markup Language, another format used by APIs for structured data exchange. The HTML hypertext markup language, sometimes used in response, though primarily for web page design. So, in order to check the API, first check if the API sends the correct signal to the database. Then API receives the response without network interruption. Then the response format is correct and readable. So for testing, we will use Postman, a popular tool for API testing. Then for creating a new request, we can select the method like get, post, then enter the API endpoint URL. To send the request, add the request required headers and body if applicable. Then check if the response matches the expected output and verify the status codes like 2200 is okay, successful request, 404 is not found, and 500 is internal server error. So what is HTML? HTML. So it is hypertext markup language. It is a programming language used to create web pages, links, and tables. However, HTML code is developer specific, meaning only developers can write or modify it. Similarly, XML, which is extensive markup language, is another programming language that organizes and stores data. So API or application program interfaces serve as an intermediaries between the clients and the server. For example, a user enters login and password. The API sends this request to the server. The server validates the login credential. Then, if valid, the server prepares a response. The API sends this response back to the client, confirming the login. So, there can be common API issues and troubleshooting scenarios. Imagine an API request breaks down multiple times during a network issue. Even though the server has validated the response, it fails to reach the client properly. As a result, the user interface cannot process the response. Even if the API request and response are all functioning correctly, the user may receive an invalid password error. The issue might lie in the database, where incorrect or outdated data is stored. So to determine if an API response is healthy, we use HTTP status code. This code indicates the state of response. So I am showing you multiple status code example. So you can use developers tool in browser, then open the network tab, click on the API request and view the status codes under the headers or response section. So the code containing two means the status code is success. There are multiple types like 200 OK, 201 created, 202 is accepted, etc. So this shows if the URL is successfully opened or not. Then there is 300, which is redirection. So it shows there are multiple choices are available, or it can redirect you to different website. So there are many codes for it. Then there is status code 400, which shows the client error. There can be bad request, unauthorized, then payment required, etc. Okay. Then there is 500 requests, which are server errors. So it shows when there is something issue with the server. So what is REST APIs? REST stands for Representational State Transfer. It allows APIs to return response in a clear and user-friendly format, often as JSON or XML. In 1999, phone calls only transmitted voices. Modern systems allow for video calls, detailed visuals, and layouts. This transformation is analogous to how REST APIs enhance the way information is transferred and represented. So, for example, you can use the www.amazon.com, go to there, then open the developer tool and click on the network tab. So you can see there, here, it is showing green. So it means it is showing status code 200. So it means the website is working properly. The specific API path following the server address, then the return data, often in JSON form. So to develop application, you need to first create the database. Then APIs are built to communicate with the server. Finally, the graphical user interface is created. So API acts as a bridge between the front end and the backend system. The HTTP status code helps to diagnose issues in API response. And REST APIs enhance data representation and transfer. So sometimes when you're browsing on Amazon and you try to search for something, you might encounter an error code like 404. Have you encountered this error before? So that's a good example of a status code. It's not just Amazon that uses this error codes. Whenever you try to access any website, you could see these kinds of errors depending on what's going wrong with the request. If everything is fine, the website will load as expected. But if there is an issue, you will get an error code. Now, if you want to check what's going on behind the scenes, you can right click on the button of any website, go to inspect, and open the developers tool. For example, if I click on the registry button on Amazon and click on inspect, I go to the network tab. You see there's a thing called registry. This is the API URL and it links directly to the server. This is an example of an endpoint. So the link you're seeing on the page is connected to the server that handles the registration process. When you click the button, it makes a request to the server through an API. The part of the URL after the main domain, like registry, is the endpoint. The full URL starting with www.amazon.com is the API. which links your browser to the server and fetches the data. When we test the API, we are doing the API testing. The user interface you see on the web page comes after API. So first, database is created. Then the API. And finally, the UI elements are placed in a page, like graphical user interface. Then URL, send, database, console, status, code. So the developer writes the API code and assigns the appropriate links to each button. So when the developer creates a link, they also define the endpoint for each button, each action. The tester then tests the functionality of each API by checking whether the endpoint returns the correct data. So when you click on the login button, it sends credential to the server here. If the credentials are correct, it returns a response in JSON format. You can check the response in the console, where it may show details like ID and login status. Based on the status code returned, you can figure out whether the login was successful or not. For instance, if the status code is 200, that means everything worked perfectly. But if it's 400 or something else, then there's an error. Now, do you think you need a graphical user interface to test this API? No. API testing can be done without GUI because we are mostly concerned with the response from the server. Mm. So let's search for find place API. This is the universal format that Google uses when searching for something. Okay? Whether you are searching on Google Maps or any other Google services, it follows this pattern. This API format is universal for all websites. So let me break down the different parts of the API for you. First, we have the server address here, which is maps.googleapis.com or www.amazon.com. This is the domain that hosts the API. Next, we have the URL or URI or the Uniform Resource Identifier. It's a broader term for the entire address. URLs are a subset of URIs. So the full URL would be the entire address, and the URI includes both the domain and the specific resources you are requesting. When you look at a URL like maps.googleapis.com slash maps slash API play slash place slash find place, what do you see? It starts with HTTPS followed by maps.googleapis.com. That's the server address. After that, you have the endpoint. If you look at the API format after the server address, the path will indicate what the API is doing. For example, in Google's API, the path could be something like maps slash API slash place slash find place. And after the question mark, we have the parameters. Parameters are specific pieces of data you want to send to the server. For example, output equals JSON or input equals place name. So, do you understand the structure now? So, to summarize, we have learned about server address, URIs, endpoint parameters, and output tag. All these types makes up for the API request. So we have learned about Google APIs, which is the universal server address or URI. Then breaking down of endpoint, then parameters, then output, the format tag. So next class we'll dive into more details example and how you can use these parts to test the APIs effectively. By the way, I would like you to all install the tools I have shared before the next class so we can start the testing of API. So if you don't have any question, I'll see you in the next class. Okay? Take care.